So hello everyone, back again with me, Sir Julius. So for today, we will learn about rational exponent and the operation of it. So without further ado, let us start our lesson today. So rational exponent is a fractional exponent. So when we talk about fractional exponent, it is related to the radicals. For today, we will learn about the operation of a rational exponent or fractional exponent. When we talk about the power of radicals, we can use this formula. A squared equals to A times A. It's the same with the exponent. Now if I have roots of 3 to the power of 2, we can make it as root 3 times root 3. So we have root of 3 times 3 or 3 square. So we have 3. So now for the next form of power of the radicals, if we have a plus b square or a plus b to the power of 2, it equals to a squared plus 2ab plus b squared. So when we have the example 3 square root of 2 plus 4 to the power of 2, it equals to the equation above. So a equals to 3 square roots of 2, meanwhile b is equal to 4. So we can write it as 3 square roots of 2 to the power of 2 plus 2 times a times b. So 2 times 3 square roots of 2 times 4 plus b squared. b is 4, so plus 4 squared. So 3 square roots of 2 to the power of 2. So 3 squared equals to 9. Meanwhile, square roots of 2 to the power of 2 is equal to 2. So 9 times 2 equals to 18. Plus 2 times 3 square roots of 2 times 4 equals to 24 square roots of 2 plus 4 square. 4 square equals to 16. So we have 18 plus 16 equals to 34 plus 24 square roots of 2. For the next one, if I have a minus b to the power of 2, it equals to a squared minus 2 times a times b plus b squared. So if I have 2 square roots of 3 minus 4 to the power of 2, now we can get a as 2 square roots of 3 and b as 4. So we can write it a squared, 2 square roots of 3 square, minus 2 times a times b, 2 times 2 to the square roots of 3 times 4 plus b squared, 4 squared. So we can calculate it. 2 squared, 4. Square root of 3 square is 3, so 4 times 3 equals to 12, and then 2 times 2 times 4 equals 16 square roots of 3 plus 4 square equals to 16. So 12 plus 16 equals to 28. 28 minus 16 square roots of 3. Now we will go to the next operation, addition and subtraction. So for addition and subtraction, there are 2 steps. The first one is we must convert the number to its radical form to make it easier. And the second one is we cannot add nor subtract numbers that have different exponents or different bases. So to do addition and subtraction, the exponents and base number must be the same. Okay, so now we will see the example. So now if I have 3 times 3 to the power of 1/3 minus 2 times third root of 3. So how can we solve it? The first one, we must change the exponent form into its radical form. So we can change the 3 to the power of 1/3. We can change it into 3 times third root of 3 minus 2 times third root of 3. So if the exponent and the basis number is the same, we can do the addition and subtraction. Okay, so 3 minus 2 times third root of 3. 3 minus 2 equals to 1. So we have third root of 3, the answer. Or we can write it to its exponent form into 3 to the power of 1/3. Now we will go to the next operation. The next operation is multiplication and division. So it's the same with rational exponent. If we have a to the power of p times a to the power of q, it equals to a to the power of p plus q. Meanwhile, for the division, if we have a to the power of p divided by a to the power of q, it equals to a to the power of p minus q. But don't forget, the base number must be the same. Okay, so now for the example for multiplication and division. Now if I have p to the power of 1/3 times p to the power of half. So when the base number is the same, in this case is p, we can add the exponent. So p to the power of 1/3 plus half. So how can we solve it? We can solve it using the fractional operation. So first, we must change the denominator. We must make both of it the same. So 3 and 2, we can change it to 6. 1/3, we can make it 2/6. Meanwhile, 1/2 is the same with 3/6. When the denominator is the same, we can do the adding operation for fraction. So we have 2/6 plus 3/6 equals to 5/6. So we have p to the power of 5/6. Or we can write it at its radicals form. 6 root of p to the power of 5. Now for our next example. Now if I have 6 squared divided by 6 to the power of 1/2. So for the division, if the base number is the same, we can subtract the exponent. So 6 to the power of 2 minus 1/2 or 3/2. So it's the same, we solve it using fractional exponent. And then we have 6 to the power of half, or we can write it in its radicals form, square root of 6. Now we will go to our next operation, power of rational exponents. The formula is the same with integer exponent. So if I have a to the power of n and then to the power of n, we can multiply the exponent m times n. So a to the power of m times n. So now for the example, if I have 4 to the power of 2/3 and then to the power of 6, we can multiply the exponent. So we have 4 to the power of 2/3 times 6. 2/3 of 6 is equals to 4. So we have 4 to the power of 4 equals to 256. Okay, so now for our next example. Now if I have a to the power of 1/3 times c to the power of -5 and then to the power of -12/5. So we must separate it. And all of the numbers in parentheses, we must make it to the power of -12/5. So a to the power of 1/3 times -12/5. and then times c to the power of negative 5 times negative 12 over 5. So now we must calculate the multiplication in that exponent. So 1/3 times negative 12 over 5 equals to a to the power of negative 4 over 5. Meanwhile, negative 5 times negative 12 over 5 is equal to 12. So we have a to the power of negative 4 over 5 times c to the power of 12. After that, remember, if we have negative exponent, we must change it into positive exponent. So equals to 1 over a to the power of 4 over 5 times c to the power of 12. Now c to the power of 12 times 1 equals to c to the power of 12, and a to the power of 4 over 5, we can make it its radicals form. So 5th root of a to the power of 4. So that's it for today. I will see you again next time. Bye.